The birth of our universe, a cosmic beginning around 13.75 billion years ago, something truly extraordinary happened. In an instant, the universe we know today sprang into existence, emerging from an infinitely small, hot, and dense point. In the very first moments after the Big Bang, primordial light surged through the cosmos, stretching across the vast emptiness of the early universe. As this light traveled, the universe itself began to expand at an unimaginable speed. Initially, this expansion was rapid, faster than the speed of light. But as the universe grew, this expansion began to slow down. Then, in a stunning twist, something unexpected occurred. The expansion began to accelerate once again. This acceleration is still ongoing today, driven by an invisible force that we call dark energy, a mysterious phenomenon that continues to puzzle scientists. Since that moment of creation, physicists and mathematicians have been captivated by the universe's mysteries. For centuries, they've worked tirelessly to understand how our cosmos works, how it began, and how it will end. Yet, despite all their efforts, some scientists dare to look beyond the boundaries of what we know. Could there be something outside our universe? A realm beyond the stars, galaxies, and the very laws of physics we understand? Could there be other universes, entire worlds that exist in dimensions we can't even begin to imagine? It's a tantalizing thought that challenges everything we know. Today, we'll dive into 5 mind-blowing theories that explore what might lie beyond the edges of our universe. We'll examine what clues we have to support these radical ideas and what they could mean for the future of science. If you enjoy our content, don't forget to give us a thumbs up, and make sure to subscribe to Simply Space for more exciting deep dives into the cosmos. The observable universe, the edge of our knowledge. The concept of what lies beyond our universe is a truly challenging one to grasp. To understand it, we first need to define what we mean by the universe. A more precise term often used by scientists is the observable universe. The observable universe is simply the portion of the universe that we can see, but even that has limits. You see, light travels at a finite speed, and we can only observe objects if the light they emit or reflect has had enough time to reach us. The universe is 13.75 billion years old, but because space itself is expanding, the light from the most distant objects we can see has been traveling for much longer than 13.75 billion years. In fact, astronomers estimate that the oldest photons we can observe have traveled about 45 to 47 billion light-years since the Big Bang. This means that our observable universe spans about 93 billion light-years across. Within these 93 billion light-years, we find everything our telescopes have captured: distant stars, swirling galaxies, massive black holes, and nebulae. There are untold wonders to discover, many still waiting to be uncovered by future instruments. Yet, the observable universe is not the entire universe. It's merely the slice we can see. Beyond this, there may be much more, vast regions of space that are out of reach for us, simply because their light hasn't had time to reach us yet. Could there be more beyond the Hubble volume? Beyond the limits of the observable universe, scientists believe there is likely much more. Some cosmologists suggest that space could extend infinitely, filled with galaxies, stars, planets, and matter similar to what we observe within our current universe. If we could somehow travel far enough, we might encounter other Earth-like planets, some almost identical to our own, where life may have taken a different turn. In fact, there's even a theory that if we journeyed far enough beyond the observable universe, we might encounter entire solar systems that are identical to ours. In these far-flung reaches of space, there could be a world where you made different choices, where you ate cereal for breakfast instead of eggs, or where you skipped breakfast entirely. And in some versions of this distant reality, you might find a parallel version of yourself, who took a completely different life path. This idea might sound incredibly improbable, but it is built on the scale of the universe, which is so vast that it often defies human comprehension. The notion of infinite space challenges our understanding of reality. To illustrate this, let's consider one of the most fundamental concepts in physics, Einstein's theory of relativity. According to this theory, objects can't move faster than the speed of light when they're near each other. However, this rule doesn't apply to objects that are far apart. When the space between them expands, it can cause galaxies to appear to move away from each other at speeds that exceed the speed of light. This doesn't mean objects are literally traveling faster than light, but rather that space itself is stretching. Theoretically, this means that reaching the edge of the observable universe would require overcoming this stretching space, something that we currently can't do. To achieve this, we would either need to travel faster than light, something most physicists believe to be impossible, or perhaps transcend spacetime itself, through concepts like wormholes or warp drives. These ideas remain speculative, but they capture the imagination of those who dream of unlocking the secrets of the cosmos. The mystery of dark flow, clues from the unknown. In 2008, astronomers made an extraordinary discovery. Massive clusters of galaxies appeared to be streaming in the same direction, moving at speeds of over 2 million miles per hour. This phenomenon was so strange that scientists could not explain it based on current knowledge of the universe. It became known as dark flow, and it raised many more questions than answers. The most intriguing question was this: what force could be powerful enough to pull entire galaxy clusters across space at such incredible speeds? By studying the X-rays emitted by these massive galaxy clusters, scientists found an unexpected shift in temperature caused by their motion. The X-rays interact with the cosmic microwave background, CMB, the radiation left over from the Big Bang. This interaction allowed researchers to track the movement of these clusters, but the results didn't align with predictions about the distribution of mass in the universe. One of the leading theories is that this mysterious dark flow is being caused by massive structures beyond the Hubble volume. These distant, unseen structures could be exerting a gravitational pull that influences the motion of galaxies across vast distances. If this theory is correct, it would suggest that the universe's structure is not uniform on an infinite scale, and that there are forces and structures far beyond what we can currently observe. Infinity bubbles, a layered cosmos of universes. When discussing the region beyond the observable universe, it might seem like we're talking about separate universes entirely. But there's another theory that suggests the rapid expansion of space after the Big Bang led to the formation of bubbles within space itself. Each of these bubbles could have formed into a self-contained universe, with its own distinct laws of physics. In this model, the universe is infinite, and each bubble is also infinite. However, space itself keeps expanding, and the distance between these bubbles grows with it. No matter how fast you travel, the space between bubbles would continue to stretch, meaning you could never reach the next one. This idea of an infinite number of bubbles, each representing a different universe with its own rules, suggests a layered cosmos, a multiverse where each bubble is its own reality. This theory adds a fascinating layer to our understanding of the cosmos, suggesting that our observable universe is just one of countless others, each with its own unique properties and possibilities. Black holes and fertile universes, new realms born from destruction. Physicist Lee Smolin proposed an intriguing theory known as fertile universes, which suggests that every black hole in our universe might act as the birthplace of a new universe. According to Smolin, each new universe would emerge with slightly different physical laws, leading to a kind of cosmic natural selection. Universes that form black holes would create even more universes, while those that don't would eventually fade away, unable to continue the process of creation. While this theory was later disproven by Smolin himself and other scientists, it remains a fascinating concept, one that sparks the imagination and challenges our ideas about the evolution of universes. It's a mind-bending idea, universes being born from the very destruction of others, giving rise to a grand cosmic cycle of creation and decay. Parallel universes, membranes and other dimensions. One of the most intriguing theories today comes from the field of string theory. String theory proposes that the fundamental particles we observe aren't point-like objects, but rather tiny vibrating strings. These strings exist in multiple dimensions beyond the familiar three of space and one of time. The theory introduces the idea of membranes, multidimensional objects that oscillate in different dimensions. These membranes could represent entirely different universes. The most fascinating aspect of this theory is the idea that the gravity we experience in our universe may not actually be native to our universe at all, it might be leaking in from another universe in a different dimension. This could help explain why gravity seems to be much weaker than the other fundamental forces, such as electromagnetism. The idea that our universe might be just one of many interacting across dimensions is an exciting possibility that could reshape our understanding of everything we thought we knew. Final thoughts: the boundaries of the universe. So, what do you think? Do unknown worlds exist beyond our universe? Does infinity truly exist, and if so, what might it look like? As we consider concepts like parallel universes, black holes creating new realms, the stretching of space, and mysterious forces like dark energy, we must ask ourselves whether these ideas are pure speculation or if there's a deeper truth to be uncovered. The universe is vast beyond measure, and the theories we've explored today are just the beginning of what could be the most profound discoveries in human history. We'd love to hear your thoughts.